11 and 12 are application problems with exponentials with a base of e. Before we go over this, I do want to just kind of rewind for a second because I don't think I made this very clear in this last video. In example 10, when we graphed this, and this was my graph right here, as you can see, this is just an exponential function. You can tell it's exponential because my variable, my unknown, is in that exponent position. It just has a base of e. And again, what does e equal? E is a number. It's roughly 2.72. So it's no different than having an exponential with a base of 2 or 1/2 or whatever number. It just now has a base of e. So it looks different, but it's the exact same since that unknown variable, that x, is in the exponent position. So I just want to make sure that that was clear before we continued. So in example 11, it says if $35,000 is invented for T years at 9% interest compounded continuously, the future value is given as S equals. So we need to graph this function for 0 through 8. So we need an X min of 0 and an X max of 8. And then we'll do zoom 0. So let's do this. Okay, and I'm going to use this e to the x power since I do need something in that exponent position. So second ln. And then instead of t, we're putting x. So we go window 0 to 8, zoom 0. And here is my exponential. So part B says use the graph to estimate when the future value will be 60,000. So this is going to be my Y2. And then we will find the intersection. So my Y2 is now 60,000. We'll hit graph. I can see the intersection on my graph, so perfect. So we'll go to calc, second calc, number 5, and then enter, enter, enter. And we are at 5.98885. Which means that we're in about 6 years. So now let's complete the table. So completing the table is going to be a combination of trace and intersections. So if I want 10 and 15, I'm actually going to go to my table. Okay, at 10, we are at $86,086. And then at 15, we're at $135,010. Now you can do this one of two ways. You can do the intersection again, or we can just search for when we get that number, and here it is right here. So 22. Okay, and then our last example for the lesson, I know it's a long one. The amount of radioactive isotope thorium-234 present at time t is given by A of t, which is in grams, and t is the time in years that the isotope decays. The initial amount present is 500 grams. So how many grams remain after 10 days? Now, we could plug this 10 in for this t and get our answer. But because on part B, it wants us to graph it, let's actually just graph it first. And then we can use that here. So let's clear out everything and let's put in our function. Again, second ln. Instead of t, we're putting in x. Also helps if you type it in correctly. And we want 0 to 100 here. So 0 to 100, let's go a scale of 10 and we'll go zoom 0. Okay, so this was my x min. This was my x max. And we'll hit zoom 0. And we get this graph here. And so now if we're at 10 days, then we have t equals 10. So trace 10, enter, and we get trace 10, enter. I'm going to just round to 1 decimal place. So 376.8 grams. Okay, and I actually did just notice that it says here that T is in time of years, and then I'm after 10 days. Those aren't supposed to be different units. I have a feeling this was supposed to be in days right here, but you do want to check for units, make sure they are in the same one. This is a typo somewhere. So this is either supposed to be years, or I think more than likely that's supposed to be days. Okay, now moving on. Part C says if the half-life is the time it takes for half of the initial amount to decay, use graphical methods to estimate the half-life of this acetate. So it tells me the initial amount was 500. And so now I want to know, when is this going to be at 250? And we'll put that at Y2. So when we have decay models, it's super common for us to figure out the half-life. So you take the initial amount or whatever's in front of that E and cut it in half. When we went over the NT table, it wanted to know the amount of time it's going to double because it was a increasing function or a growth function. So growth functions, it's very common to ask the double. Decay functions, it's very common to ask for the half-life. Now I'm going to go over here and put in 250 and hit graph, and I can see my intersection. So we'll go here to calc. Number 5, enter, 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 and we get about 24.5. So we did this, we found the intersection, and we got that X is about 24.5. So I haven't said this one time, which is very strange since this is our 5th application problem, that word problems need word answers, or at least units. So what are we talking about here? We have our half-life in about 24.5, and I think my T was supposed to be in days. So might be 24.5 years, but I think that's supposed to be days.